back and forth when we go to the next page. But the first group of identities are called reciprocal identities. A reciprocal is when you flip something or you take 1 over something. So underneath, if you look at the 3 that are underneath, the cosecant, you already know its reciprocal identity. The cosecant is equal to what? How would you find cosecant? 1 over y. So Virginia said 1 over y. Well, what do we know is y? What function is y? Sine. So the reciprocal of the cosecant is 1 over the sine. Well, now if you think the opposite of that, if you want to know what the reciprocal of the sine is, the reciprocal of the sine would be 1 over the cosecant. So both of them can be thought of as reciprocals. So the cosecant is 1 over the sine, but the sine is also 1 over the cosecant. If it's reciprocal one way, we can do the reciprocal the other way. So we used to say secant is 1 over x. Well, 1 over x is the same thing as 1 over the cosine. Because x and cosine are the same exact thing. X on the unit circle is the cosine. Cosine is also 1 over the secant. And then the cotangent we can find by taking 1 over the tangent, or the tangent we can find by taking 1 over the cotangent. So those are all reciprocals. A reciprocal is when you have 1 over something or you flip something. So each one of them has a reciprocal identity. And the next two are the quotient identities. So a quotient means you should have a fraction. Chelsea, do you have an idea what the quotient identity is for tangent?
Sine over cosine.
So it's sine over cosine. Because we used to say it's y over x. Well, y is sine, x is cosine. So now we have a quotient of 2 functions that we can use to find the tangent. We can do the same thing with cotangent, just flip it around and say cosine over sine. And that's because tangent and cotangent are reciprocals. So if you know the tangent, you can flip it over to find the cotangent. So cosine over sine. So the last 3 are the ones that nobody could remember. So it would have been like the last part of the flashcards that you probably were looking at. The Pythagorean identities are based off of the Pythagorean theorem, hence the name. And if you have a triangle, we would say that this is the x side because that's your cosine. This is the y side, and we said this was 1. Well, the Pythagorean identity works very similar, except it goes along with the Pythagorean theorem. If I want to find the length of the side, I would take x squared, or cosine squared. We would take y squared, or sine squared. And then we would also have 1 squared, well, 1 squared is just 1. So it's using the Pythagorean theorem, but applying it to the fact that y is really cosine, or sine x is really cosine. So that's the first identity. The other 2, there are proofs. And if you have Mr. Warnock, some of you may have had him, he loved proofs, loved proofs. I have a proof,
No,
but I'll spare you.
thank you.
You guys are like, thank goodness. So 1 plus the cotangent squared equals the cosecant squared. Or 1 plus the tangent squared is equal to the, hold on, yeah, secant. I need an S here. There we go, secant squared. So those are the other 2 Pythagorean identities. They're based off of the first one, and as I said, we could work through a proof. And at some point we will be working through a proof, but that'll be like chapter 5. But these are the other 2. So these 3 are one of those lists on the trig facts. So today we're just going to kind of show you a couple of different ways or uses for them, and then we will work with them more as we get through some of the trig. So the first example that we're going to look at, maybe, here it is, kind of sounds like the problem you did yesterday. You're given the fact that sine of an angle is equal to 1/3, and it says the angle is an acute angle. So you could draw a triangle. The sine is the opposite and the hypotenuse. So the opposite side would be 1, the hypotenuse would be 3. That's one way to look at it. Another way to look at it would be to use the trig identities, which is what this question is asking us to do. It says find the other trig functions using trig identities. So we're going to try and use those facts. That's what an identity is, a fact. So a square has 4 right angles, 2 pairs of parallel sides. Those are facts about squares. These are facts about trig functions. So we want to see if we can use some of those facts to help us find the other 6 trig functions. So if you know sine is 1/3, what other function can you find without doing any work? Chelsea? Cosecant, because cosecant is its reciprocal, and it's just 3. So that's an identity. We've been using it as a reciprocal function, but it actually is an identity as well. So now that I have these 2, let's see if we can use these 2 to help us find the other 4. So look at the board. See if you can kind of decide which one of those identities you could use. And the fact that cosecant is 3, or the fact that sine is 1/3 to help you get another function. Brandon?
1 plus cotangent squared equals cosecant squared.
Okay, so he said 1 plus the cotangent squared is equal to the cosecant squared. Which one of those pieces can you fill in for?
The cosecant squared, you can put that in for 9.
Yeah, so the cosecant squared, well, we know cosecant is 3, so you can replace cosecant with 3 and square that number because it's cosecant squared, so that becomes a 9. So these functions work just like a variable. It's just like x. If you knew x was 3, x squared, then is 9, and you can replace that number into an equation. God bless you. Now you're solving for the equation for the variable. Well, the variable is that whole piece there. It's that cotangent squared. So we would take the 1 to the other side. This is now algebra. So I've taken trig and I'm plugging in algebra now. How do you think you'd get just cotangent if it's cotangent squared, Brandon?
You take the square root.
Yeah, just like if it was x squared, we'd take the square root, so it's cotangent squared. So now we just have cotangent, and Brandon, the square root of 8 reduces to?
2 times the square root of 2.
Awesome, Brandon. So now we have cotangent. By using the cosecant instead of a triangle. The triangle is probably way easier. I know you're saying, yeah, way easier. But this is like really is algebra behind the problem, instead of thinking of it with a triangle. All right, so if we know cotangent, we can figure out tangent by taking 1 over the cotangent. So minimal work here. You know the cotangent, take 1 over it, multiply by the denominator to rationalize it, and we end up with the square root of 2 over 4. So now we have tangent. Now we've got 4 of them. Okay, so let's go back on the other side. Let's see if we can use sine. We need cosine and we need secant. And right here is an identity that has cosine. So Virginia, how do you think that would look if we want to use that identity? Okay, so you're using the bottom one. What if we use sine squared plus cosine squared equals 1, just to try and use the sine value? Yeah. Anybody know how you square 1/3? Really easy, without doing a lot of mental work. Virginia, what do you do to square 1/3? Yeah, just do 1/9. So now we have 1/9 plus cosine squared equals 1. So we have to subtract 1/9. I think you've all become better at using fractions. Chelsea, 1 minus 1/9 is 8/9. I think at the beginning of last year you always just pulled out that calculator in hopes to use it, and hopefully now you're feeling a little more comfortable with fractions. So you're taking the square root of 8 and the square root of 9. which Brandon told us from the previous one that the square root of 8 was 2 square roots of 3. The square root of, how about 2 square roots of 2? The square root of 9 is 3. And then the last piece, like this problem could be so much easier if we used a triangle. Yes, I get that. I know it would be a lot easier. So this is just kind of working through a different way, a different approach to the problem. So the last thing we have to find is secant, which means take the cosine and flip it around. That's probably the easiest way that we can get secant. Take what you have, flip it around, use the reciprocal, and then rationalize. So this would be 3 square roots of 2, and then over 4. So is a triangle a lot quicker? Yes, definitely. Using an identity is an algebraic approach instead of a more like geometrical approach.
Are we gonna have
Probably. So I'd like you to flip the page, and I'm going to actually go to the bottom of the page, and we'll see if we can work back to the top. I just want to continue using the identities so you can see how else we can use them. So if you look at example 5, so we're now at the bottom of the next page. I've got the identities over there because we're going to try and use them again. It says to use the identities, the fundamental trig identities, basic identities, facts for trig functions, to transform one side of the equation to the other. What's another word for transform? Sabrina? Move, not move. So transform would not be move. I'm thinking of it like CH. Change, right? Transform means change. So we're going to try and change one side to look like the other. So if you look at the left side of the equation, we're going to try and change that to be 1. That's our goal. So we're only going to work on the left. We want to see if we can change it to become the number 1 by using the identities in substitution. So substitution means change, replace with whatever it's equal to. So if you look at sine times cosecant, so sine theta, cosecant theta, how can we change that? What's one thing that you could kind of replace in the problem? So you want to take something out, replace it with something else. So look at those identities. Sabrina, you have an idea?
You can make cosecant theta just 1 over sine.
So one of the reciprocal identities says the cosecant is equal to 1 over the sine. So we can use substitution, take out the cosecant, and replace it with 1 over the sine. Substitution enables us to take a piece out and replace it with whatever it's equivalent to. Sabrina, what happens then since we use substitution?
The 2 sines cancel. We just left the 1.
Right, the 2 signs now cancel. So we changed the way the problem looked by taking out a piece and replacing it with something else. And now the 2 signs cancel, and we end up with 1 equals 1. So let's see if we can look at the second problem. I've had no luck with technology today.
Good afternoon. Please pardon this interruption. Attention all students attending the Falling Water field trip with Mr. Cassandra tomorrow. Students will meet in the main lobby of the high school at 7:55 and leave promptly at 8 a.m. Please do not wear blue jeans or tennis shoes and don't forget lunch money. Thank you.
Okay, so now kind of treat your brain, train it to think algebraically, even though we have cosine and sine. When you have parentheses in the problem, algebraically, what would you be thinking to do? Chelsea? Foil. We're going to foil, because when you have parentheses, that's usually what it means. We want to multiply here. So we have 1 times 1, that just makes 1. 1 times negative sine is negative sine. Sine times 1 is positive sine. And then what do you think sine times negative sine is? Eris, what do you think if we had sine times negative sine? What would that be? What's x times negative x? It is squared, yeah. And then we still have this cosine squared. That's what we're trying to get it equal to. Trying to transform it to be cosine squared. Kate, what happens with this problem if we do a little simplifying?
The sine of the square cancel.
Yeah, so the signs in the middle cancel. And we have 1 minus sine squared equals cosine squared. Okay, so here's where the identity part comes in. Now we're going to try and take a piece out and replace it. So this really says 1 minus sine squared, is equal to cosine squared. Looking over at the identities. The number 1, if I take that out, what can we replace it with, Brandon?
Well, I was looking at the first one that says sine squared plus cosine squared equals 1.
So we can take it out and replace it with exactly what Brandon told me. 1 is equal to sine squared plus cosine squared. So we're taking the 1 out, we're replacing it with whatever it's equal to. That's substitution. So substitution says you take something out, you replace it with an equivalent expression. And then we still have minus sine squared. And then my sine squared and minus sine squared cancel, and we have cosine squared equals cosine squared. It's kind of like a logic puzzle. Virginia? Only manipulate one side. So you can't move something to the other side. So you have to stick with one side of the equation. Questions?
So you couldn't just take 1, so you couldn't just subtract.
Right. So you can't, like the equal sign is almost like a barrier wall. You can't move across the wall, climb across the wall. I wanted to get to another problem, and I didn't. Probably because the lovely technology that we have. So your homework tonight is in the book. Tomorrow.